Okay, this video is for the derivative of a function. And as you're flipping through these notes, you may notice that I have three different definitions of the derivative. To try to keep this as straightforward as possible and to not confuse you, I'm changing the way that I'm going to teach it this year. Okay, so up here in this corner, this is the only way that we are going to do the derivative by definition. Okay, later on in this chapter, you're going to learn some shortcuts. But if I ever say that I want you to do the derivative by definition, that red cloud that you're looking at is exactly what I want you to do. So let me kind of go through and cross off some stuff that I am not going to do in these notes, okay? I'm not going to do this. Okay, I know I did it last year, but I'm not doing it this year. I am also not going to do this. Okay, I'm only going to do that red cloud, which is also right here. Okay, it's the only definition that I'm going to use. So that being said, I'm gonna jump right into example number 1. All right, so I know there's some other stuff at the top of the note page. For now, I just want to make sure that you can do the derivative by definition. Okay, now you can see I put the definition here so you can look at it instead of the one that was there. All right, so for this problem, example number 1, here we go. I don't have a pen. Here we go. F prime of x is going to equal the limit as h approaches 0. And you can see right here, I'm going to put x plus h into this function, which is going to give me 3 times x plus h squared plus 5 times x plus h. And then I'm going to subtract the original function, 3x squared plus 5x. And this is all over h. Okay. And then I'm going to write equals the limit as h approaches 0. And yes, you do have to bring that notation down every time. All right. So now, let me highlight what I'm going to do. This part right here, I'm going to FOIL and distribute at the same time. If that's something that's not making sense to you, please come into tutorial and I'll be happy to explain. 3x squared plus 6xh plus 3h squared. Okay, next I'm distributing this 5 plus 5x plus 5h. And then lastly, I'm distributing that negative 3x squared, negative 5x. And this is all still over h. Okay. And again, the limit notation has to come down because I haven't been able to take the limit yet, right? I haven't been able to plug in 0 for h yet. Okay, but now some stuff is going to cancel out. That cancels with this. That cancels with that. And based on what's left, I can factor out an h. And I'm left with 6x plus 3h plus 5 all over h. And now when those h's cancel, I'm officially able to take the limit. I can put 0 in for x. Excuse me, not for x, for h, giving me 6x plus 5. So this is the derivative. That's the derivative anywhere. Okay, but if you look really close, this problem right here is asking me specifically to find it at 2. So f prime of 2 is 6 times 2 plus 5, which is 12 plus 5, which is 17. Okay, so I've slid it up just a little bit and, oh, sorry about that. And I added in over here on the right-hand side, I added the definition so that you can see it. Okay, so let's do the derivative of this one. So g prime of x is going to equal the limit as h approaches 0. And I'm going to put the x plus h in there. So 9 over 2 times x plus h minus the original function. And this is all over h. Okay, now I need to simplify that complex fraction, which means I am multiplying everything, every single thing, by 2x times x plus h. And I'm going to see if I can get this all to fit here. 2x times x plus h for that fraction. 2x times x plus h for this fraction. And in the denominator, 2x times x plus h. All right, so let me see if I can get this to simplify. All right, for the first fraction, the 2 cancels, the x plus h cancels. When I multiply what's left, I have 9x. Over here, the 2x's cancel. So I'm going to distribute this negative 9 here and here. Minus 9x minus 9h. And then in the denominator, nothing's going to cancel, and I'm not distributing. I'm going to leave it as 2xh times x plus h. Okay, let me switch colors. 9x minus 9x, that's gone. It cancels out. This x now cancels, excuse me, that's an h. That h now cancels with this h. Okay, and now because that h that I just canceled out is gone from the denominator, now I can actually take the limit. So when I put 0 in for that h, you can kind of see my numerator is negative 9. My denominator ends up being 2x squared. Okay, so this is my derivative. G prime of x equals all of that. This particular problem is asking us to do it at x equals 1. So G prime of 1 is negative 9 over 2. All right, so I'm going to continue, and I'm going to do example number 3. And again, I'm doing it with just the one definition. The other ones are still there. You can still look at them. You can play with them. You can try them if you like them. But I'm just trying to keep things as straightforward as I can this year to get you guys through calculus. All right, so for this one, I'm going to, again, the definition is down below. Okay, so if you're trying to find the definition, it's here. Here we go. F prime of x is equal to the limit as h approaches 0. Okay, so when I put x plus h under that radical, I get x plus h minus 2. And then I'm subtracting the original function, and this is all over h. Okay, now I'm going to have to multiply this by the complex conjugate. It's the only way that I can get things to cancel out. So the top and the bottom, I'm going to multiply by x plus h minus 2 plus the square root of x minus 2. Top and bottom. All right, so let's see what this next line looks like once I actually FOIL that. Okay, so on the top, my first terms are going to come out, x plus h minus 2. The inners and the outers, right? Or if you're doing this on a box, right? The diagonals are going to cancel each other out. And I'm going to have minus x minus 2. And then my denominator, yeah, it's going to look gross, but that's okay. I'm going to leave it all with the radicals and everything. Okay, so now let's simplify this just a little bit. Can you see that this is going to be a negative x, which will cancel with this x? And that this is going to be a positive 2, which will cancel with this negative 2. So all I have left up top is h. So then that h cancels with that h. And now I can actually take the limit, because making this 0 now doesn't cause a problem. So it looks like my derivative is going to be 1 over the square root of x minus 2 plus the square root of x minus 2. Well, that actually simplifies. That's 1 over 2 square root of x minus 2. And if we want this very specifically at a point, which is 6 in this case, f prime of 6 is 1 over 2, 6 minus 2. That's 1 over 2 square root of 4. That's 1 over 2 times 2. That's 1/4. All right, let's continue. Okay, so some things that you can read here in this little definition. Okay, if f prime of x exists, we say that f is differentiable. Okay, that's just, all that means is if I say the word differentiable, it means I'm able to take the derivative. Okay, and then here's some more notation because we know how much we love notation. So if your function is given in this notation, you could say that the derivative looks like that. You could also say, if your function's given as y, that the derivative is dy dx. You could also say, if your function's given as f of x, that you have d f of x dx. And lastly, if your function was given as y, you could say that the derivative is y prime. Okay, those are all fairly interchangeable. Okay, I wouldn't do this. Like if your function was given as y, I wouldn't say this because it's hard to follow. All right, so make sure you're kind of using one of those four that logically follows. Okay, so let's try this next one. Let's find the derivative. I'm going to call that f prime of x, and it's the limit as h approaches 0. I'm going to put x plus h in there, x plus h squared plus x plus h. Then I'm going to subtract the original function all over h. The limit as h approaches 0. Now I need to FOIL and combine like terms and distribute, all the good stuff. X squared plus 2xh plus h squared plus x plus h minus x squared minus x all over h. Let me switch colors so you can see what I'm canceling. X squared and negative x squared, positive x and negative x. So when I factor out the h, I'm left with 2x plus h plus 1 over h. Those cancel. And I finally get to take the derivative. Or excuse me, not the derivative, the limit. I finally get to take the limit. I finally get to change this into a 0. And I'm left with 2x plus 1. Okay, moving on. Okay, so this is given in terms of y. So I'm going to call the derivative dy dx. All right, still the same definition. The limit as h approaches 0 of 3 over x plus h minus the original all over h. All right, and this is where I'm going to multiply all three of these by x times x plus h. X times x plus h. And the denominator too, x times x plus h. I am simplifying the complex fraction. Here, these cancel. Here the x's cancel, and I'm going to distribute the negative 3. So negative 3x, negative 3h. And the denominator I'm leaving as h times x plus h. All right, now let's see what cancels. 3x minus 3x is gone. That h now cancels with that h. And now I'm officially able to take the limit. I get negative 3 on the top. I get, if this is a 0, I now have x squared in the denominator. Okay, so now, oh, wrong way. Let's try this. All right, so I'm going to say this, and you're going to hear me say this over and over and over and over again. The derivative helps you find the slope of the tangent line. The derivative helps you find the slope of the tangent line. All right, so I'm gonna use some highlighters on this graph and see what I can do about graphing the derivative, okay? Okay, so what this problem right here is asking me to do is if this is f of x, if this is just some random function, over here they want us to graph the derivative of f, meaning all those slopes that you can kind of see listed, right? There's a bunch of them listed. Slope of 4, slope of 1, slope of 0, right? All those slopes. They want us to transfer them over here onto this graph. Okay, so I'm going to try to color code this just a little bit. Okay, so let me grab like a yellow highlighter. And I'm going to highlight. That's not what I wanted. That's what I wanted. Give me a sec. Okay, so I'm going to highlight the things that have a positive slope in yellow. So it's this is positive, still positive, still positive. And over here, I have some positive slopes. The stuff that has a slope of 0, I'm going to highlight in green. So there's one right here. There's another one right here. And anything that's negative, I'm going to highlight in blue. So all of this that's on the downward, right? That all has negative slopes. Now, if you're not sure which is positive, which is negative, and which is 0, zeros occur at maxes and mins. All right, so think about this picture over here as being a roller coaster, right? And the spots where you're like on your way up, those are positive slopes. And the parts where you're either at the top of a hill or the bottom of a valley, those are slopes of 0. And the parts where you're like, wee, on the way down, those are negative slopes. Okay, so now what I need to do is to try to transfer what I just did onto this graph on the right. I'm going to start with the C value, that C ordered pair, and the F ordered pair. Okay, because there's a slope of 0, and it looks like it's happening right when x is 2. That's going to be that dot, and this F happens at 6. That's that dot. Okay, so then this A spot right here, this A spot happens at 0 and it has a slope of 4. 1, 2, 3, right here, right? A slope of 4. And it looks like B, which is supposed to line up with 1. It may not be doing the best job, but it's a slope of 1. Okay. And then D, which is at 3, is a slope of -1. E, which is at 5, is also a slope of -1. All right, and then it looks like it increases after that. So I'm going to connect these dots and I'm going to highlight so that hopefully you can see what the heck I'm talking about. Let me just connect these dots in a fairly nice way, like that. And let me go back and highlight so you can see. Remember how over here I'm trying to make this really bold and yellow? This was all positive slopes. That's this. Okay, and you may be saying, that doesn't look positive. Well, it does if you consider that from 0 to 5 is positive, right? And then the blue part, this part right here that I highlighted in blue, that's this part down here. Oh, that's not blue. That's this part. Okay, and again, when I'm talking about it being negative, I'm talking about the fact that less than 0 is a negative number, right? And then this yellow part, that's not yellow. This yellow part over here is this part over here, where it, again, it comes back up above the x-axis. That's where things are positive. Okay, we will definitely play more with this in class. All right, so then this last example here. Okay, this problem is asking us to do this sort of in reverse, meaning this picture over here is the derivative. These are the slopes. Okay, so I think you can see that this is a constant slope of 2. And this over here is a constant slope of -1. Okay, so from 1 on, right? When x equals 1, and to the right of that, I should have a slope of 2. And to the left of 1, I should have a slope of -1. And then check this out right here. It's saying that f of 1 is actually equal to -1. So I actually have this dot right here. Okay, so let me use this bit of information. To the right of that, I should have a slope of 2. I'm not sure why that's not straightening out, but I'm going to have to go with it. And to the left of it, I should have a slope of -1. Right, so that line. And I wish that would straighten out, but it doesn't want to for whatever reason. And I didn't even connect the dots. I'm ashamed of myself. Let's try that again. Okay, that's a little bit better. Okay, so that should be 2.1.